Alright guys, today we're looking at starting our third chapter, and it starts off with trig proofs. Luckily for you guys, trig proofs aren't quite like geometry proofs. They're not where you have to list that something exists because of some postulate that you have no idea what its official name is or anything like that. They're more of a mathematical type proof where you're essentially working something out to make one side look like the other side. So, just to give you a quick example here, in a trig type proof, what you would do here is you would pick the more complicated side, which is this side here. Usually it's the least simplified side, and you basically want to simplify it to make it look like the other. And that's how you do a trig proof. So like in this example here, I would add all of this up, and there should be another plus 1 here. I mess this example up every time. But here you would take 2x plus x, which is 3x. And it should be 1 plus 1 plus 1, so that would be plus 3. And then you would factor out a 3. And that's it. So that's kind of what you're doing here in a trig proof. Now the tricky part is that you have, instead of basic algebra like I had there, you have to use these identities that we've covered, and you have to be able to apply them in situations, and that's what makes this hard. So it's highly recommended that you learn these identities, because, or at least when you're first working these out, have them on a sheet that you can easily and readily access to help you work your way through. One thing I do want to talk about is we can actually expand these. As long as we follow basic mathematical rules, we can add or subtract a cosine here. Like subtract the cosine of both sides to modify this identity to make it fit a situation that we have. And what I mean by that, let's take this identity. If I can subtract a cosine from both sides, and if I do that, this identity now would have that sine squared equals 1 minus cosine squared. And I could use that identity because what I did was, exists in mathematics land. I didn't just magically pull numbers from anywhere. I just subtracted something from both sides. I followed all basic math rules, and so I can do that. Likewise, I could also subtract the sine, and if I did that, I would have this new identity. Oops, that should be a sine, not a cosine. And so writing these out would be a good idea because it allows you to, have something readily accessible that you could use to see all the different variations. So here you see, here's all the other ones worked out. So make sure you know these, at least write them down, because they are very helpful when you're trying to first learn how to do all of these types of proofs. So some basic guidelines we're going to use for trig proofs. One, you will usually want to work the most complicated side first. That means the least simplified. Now, that's some good spelling on my part. Good thing I'm not an English teacher. Least simplified. Writing with a mouse is very difficult. Next thing, you want to look for substitutions if possible. That makes your life a lot easier, makes it a lot simpler. Next thing, you're looking for algebraic operations like adding, subtracting, distributing, combining, etc. Since these are expressions, you can't divide things by both sides. You can't multiply something on both sides. You're basically treating one side like it's an expression. So dividing and multiplying both sides of an equation does not work. If you're stuck, you convert everything to sine or cosine. If you think about all those identities and take a second look at them, they can all be written in terms of sines and cosines. So sometimes it's easier if you're stuck to see them in that format so you can cancel things. And then lastly, make sure you're keeping an eye on the side that you're not working on. It's really simple, or it's really easy to basically simplify something to the point where you basically do a big loop and you're back to where you started because you weren't paying attention to what you're doing. So keep an eye on where you're trying to get to, because that will save you a lot of time and frustration. So we're going to do a couple examples. We want to show each step. We want to work only one side. We want to show our work going down. Don't try working horizontally. It messes it all up. So here's a basic one. So I would look at first, this side is the least simplified, so I want to work on it together. Now here, this is one term being multiplied together. This is just one single thing, so I'm going to want to combine this somehow. One thing I can do is I could substitute something for the secant to where then I could combine it with the sine and get one identity. Because keep in mind, tangent, if you think about it, we know that's sine over cosine, right? So we already have the sine. We have that guy here. What we need to do is work with this cosine and get that secant down into a 1 over cosine like that. So the identity I'm going to use is this reciprocal identity where secant equals 1 over cosine. Multiply that by sine. I get sine over cosine, which is tangent. Put a little check mark there and make sure I got it. So that's really all we're doing here with trig proofs. Let's look at this guy here. This one's kind of tricky. You see here cosecant squared, cosecant to the fourth. So one thing to keep in mind is, I'll reveal a hint, is that you're not really dividing it both sides. You're not taking the square root of both sides. Any operation that you have to do to both sides of an equation, you don't do it in these. So my hint I have for you guys is to factor. So the greatest common factor would be a cosecant squared. So let's try taking that guy out. Cosecant squared, which leaves me a, that's terrible. A cosecant squared minus 1. Now, what kind of identities do we have that fits this? So take a second and look at your sheet. Alright, after looking at your sheet, hopefully you realize that that is a cotangent squared. And then this guy here, the cosecant equals 1 plus cotangent squared. The reason why I knew to do that is because I'm trying to get these changed into cotangent. So I look at my identity sheet and I determine, is there any identities that could take me from a cotangent to, or cosecant to a cotangent. I then distribute because I want to make it look like the right hand side here. So I have a cotangent squared plus cotangent to the fourth. That's what I'm looking for. So that's a basic rundown. We'll do a couple extra examples in class like this one if you want to write it down. And pause the video here so you can finish writing it down. And then now this is the last example we'll do in class. So pause the video here if you want to write it down. And then we'll have worksheets to work on. So that's a good start to our trig proofs day. Hopefully this makes sense when we get to class.